Hello everyone, Mr. McVeigh here. What I have for you today is exponential functions. In the past, we've discussed linear functions and quadratic functions. And now we're going to discuss basic. In this case, we're going to discuss basic exponential functions. The form of a basic exponential function is f of x, the function, or you can say y, equals a times b raised to the power of x. F of x or y is called the dependent variable. X is the independent variable. A lot of times with exponential functions, x will be a t. You might see that as a t, and it represents time. A is the initial value of the function. B is called the change factor. And b is always greater than 0. Exponential functions graph in two different ways. They're either increasing, and another word for increasing is growth, and an exponential function is increasing or growing when the value, the change factor, b, is greater than 1. So if b is greater than 1, it's always increasing to the right. So it'll be uphill to the right. So increasing and growing looks like this. The initial value, a is also known as K-N-O-W-N. A is also known as the y-intercept. So the y-intercept, this is the y-intercept in this case at the origin. Y, A is the initial value. You'll see more when we start plotting these in a few minutes. Increasing uphill to the right. Decreasing, or another word is decay. An exponential function is decreasing or decaying when b is between 0 and 1. So our function is y equals a, initial value, b to the x. And this b is always between 0 and 1. And you'll notice that decreasing or decaying is going uphill to the left or either downhill to the right. Downhill to the right. Exponential functions have what's called asymptotes. An asymptote is a line which the graph gets close to but never crosses or touches. In this case, this red line is our asymptote. This is an increasing exponential function. You can see it's increasing uphill to the right. And this distance right here, this distance between this axis and the function in blue always gets smaller and smaller and smaller as we go away, but it never ever touches or crosses. It's called an asymptote. In our basic equations, the asymptote is always going to be the x-axis. Later, when we start talking about translations in another video, we will translate our function up or down, our exponential function up or down, and the asymptotes will change locations from the x-axis. Let's look at some examples how to plot an exponential function. Okay. Our equation, again, is y equals a times b raised to the x. You'll notice in this case, my a coefficient is 1. It doesn't say 1, it's understood to be 1. And b, in this case, is 2. I've already written these down, but I picked some points. I picked some points to plot this. So my independent variable, x, I picked -2, and so at -2, I get 0.25. That is right about here. At -1, I get a half. That's right there. At 0, I get 1. And you'll notice that 1, A is 1. So this value is my initial value, A, and it's 1. So it's my y-intercept. So A is 1. At point 1, x equals to 1, I get 2. And x equals 2, I get 4. And from this, we can see that our function is increasing. Like I said before, on these basic equations, the x-axis here is the asymptote. That's the asymptote. And my function, I'm going to plot him in a different color. My function never touches this x-axis, so it just keeps getting closer and closer and closer, smaller and smaller and smaller. It's increasing like that. And from this, we can see that my domain keeps on going to the left forever. It keeps going up forever. So my domain is all the real numbers. And my range, you notice my range is up and down, or the y values, so it never reaches, in this case, this is the x-axis, so it never reaches y equals 0. So my range is y greater than 0. So it's increasing. The domain is all real. Y is greater than 0, but not equal to. Okay, another example. Here we are again. Y, the original equation, y equals a times bx. Again, a is equal to 1. The coefficient is 1 right here. B is equal to 1/4. Okay. Now we know that B, this time B is less than 1, but it's greater than 0. So in that case, we know that it is decreasing or a decay. So I'm picking some points here to plot. So at 0, I have 1. Notice that's the A value. That's my initial value. At -1, I have 4. At -2, I have 16. So that's way up here. At 1, I have 1/4. And at 2, I have 0.065. That's getting close right there. That's getting closer and closer to my x-axis. And so this thing plots. It comes from way up here. And then it turns. It's decreasing. And it gets closer and closer to the x-axis, the asymptote here, but it never touches that asymptote, which is the x-axis at x equals 0. I'm sorry, at y equals 0. So this function is decreasing. My domain, again, it goes all the way from -infinity x to +infinity x. So my domain is all real numbers. And my range is y greater than 0 because my asymptote is at 0. One last example. Again, my original equation, my basic equation is y equals a times b to the x power. In this case, a equals 2 and b equals 1/3. So again, b is between 1/3 is less than 1 and it's greater than 0. So we know that this thing is decreasing. So it's going this direction, decreasing. Decreasing. I pick some values. Okay, at -2, I have 18, way up here somewhere, out of view. -1, I have 6. At 0, I have 2. Notice this time it's not at 1. See, my initial value is at 2, so my y-intercept, A, is equal to 2. There it is. It's always the first point you can plot. When you know what A is, when you know that A value, you can always plot that as your y-intercept, and that's 1 right away that you get. At 1, I get a 6, I'm sorry, 0.6, which is almost 2/3, so it's a little bigger than a half. And then I have 2 is 0.2, which is less than a half. And you can see I'm coming from way up here. It's decreasing, and my asymptote is the x-axis. My domain is all real numbers, and my range is y, again, greater than 0. And that is all I have for you today. If you like this video, please like if you'd like to see more. Mr. McVeigh saying goodbye.